This video we talk about linear mean square estimation. So linear mean square estimation, if you have a linear combination of a random vector or some random variables, which is you multiply the first one by a real number, you multiply the second because plus a2 x2, the second random variable, you multiply the second real number, and so on. So this is called a linear combination of random variables x1 to xn. So if you write a to a vector, so if your x is, if this x is x1, x2, xn as a row vector, and then if you write a as a1, a2, etc., n, so denote this by a real vector of size n, and this is a random vector, row random vector of size n. So you could consider this as any linear combination as a linear estimate of S. So some of these points, if you tune these parameters in vector A, if you choose A properly, this estimator is a good estimator if these values are not good or not selected well, if they are not tuned, if they are not learned very well from your data, this is not giving you a good estimator. So you could try to optimize this estimator by minimizing the distance between the error between S and S hat. So what we consider, this guy is the error between S and S hat. Now then this is S minus S hat, so this is equal to error, but then S minus S hat to the power of 2 is equal to the squared of the error. And then when you put another expected value on this guy, will become mean, the mean of the squared of the error. Okay, so this is why we call it mean square error. So we want to minimize that. We want to reduce the mean of the squared of the error, because the error is random. It could be positive, negative. If you minimize it or maximize it, it doesn't do anything. You put a squared to make it positive. And then because this is random, you want to make it deterministic. You apply the expected value to make it a real number, and you minimize the expected value of that. So if the estimation error is minimum, then S hat is called the linear MS estimator of S. So if this function is minimized, we call it linear MSE estimator of this. So you can calculate the derivatives and then try to find the optimal solution for this one.